And now we have to write down an input file for the solver for the CCX, and that input file must be matching with all steps that we have done so far, such as the input file must be matching with the mesh, with the FBD, with the boundary, with the deload, with all these things. And for that, we will save as another file, input file. We will name it as this one, .ini, save. Okay. Okay, now this one has been saved. Okay. And then we will get help from the website to write down the input file. Okay. We will write down heading model CalculiX beam input file. Let's make the first letters of each word capital. Okay. Here, heading this command. This is corresponding to comments. Whatever of the sentence that are following heading will show up on the top of the output file later while we will solve for CCX. This one will be appearing on the top of the file, and that's because of heading command. After that, we continue to write down include input equal beam dot mesh. Okay. Here, this command is going to include, or it's going to insert the contents of beam.mesh. This one. The contents of beam.mesh will be inserted here. And here, okay, there's a point later, I will explain it. Then boundary include input equal to fixed /123.12. Here we don't have to put space. Okay. And here, after this one, fourth line, it's assigning boundary. This command is allowing us to include and insert the, okay, wait, it doesn't have to be capital. Okay, here is the difference. In beam.mesh, this about nodes and elements. There's already a command of node and element. I'm showing here. Open. Boundary and mesh. And then boundary. Okay, here. For the boundary, we see As we had said before, that if sentence and words coming after 2 stars, it means that sentence is count as comment. It's not a command. But if we see there's no command here, there's no command. This is not command, this is comment. But in Beam, we see we have command node. Following that, we have element command. Yeah, here, element command. So that's why here, for inserting mesh, we don't have to assign, or we don't have to force the inserting of beam mesh file by any command. But here, for boundary conditions, since we don't have any command inside boundary condition, that's why first we have to use boundary command in the purpose of forcing this file to be inserted. That's the difference between mesh and fixed mesh file and boundary file. After that, material. Okay. From line 1 to line 3, it's all about the model. Starting from line 3, starting from 4 to 5, it's about boundary condition, and from 6 to 9, it's about the material. Okay. Material. Okay, we are starting a new command, material. We are defining the material, and we are giving a name to that material. It's EL, and that EL corresponds to elastic. Following that, we are defining elastic, and the material is linear isotropic, and we are defining that it's a linear isotropic by defining the Poisson ratio and modulus of elasticity under elastic command. So here, after assigning elastic command, we will prove that the material is linear isotropic. Following that, we will define it's a solid section, and we are also assigning that the whole set is e-beam. And if you remember that after making beam mesh format file, the nodes and the elements, they all got listed into a set. The name is eBeam. So all our nodes and elements are included inside a set called eBeam. So here our material is going to be assigned into eBeam, of course. So first we are defining its solid section, and then we are assigning that our complete set is eBeam. It's the set that contains nodes listed and elements listed. Following that, we are assigning the material, and the material is EL as we had defined elastic previously. After that, we will skip to loading step, and we see that from line 10 and line 18, all of it is about loading. So it starts from step and ends by in step. Okay, we are done with writing. Here, a command step starts assigning the loadings, and after that, the static command tells that the loading is static. It means it's going to apply slowly, and then the next command will be deload. It means it's distributed load, and of course it was distributed load applying on space of an element. Following that, we are including and inserting the contents and information of this file into solver CCX. And again, these commands, especially deload, is forcing to input and insert the information inside this file load.dlo into solver, since there is no any command inside load.dlo. And let's see if there is no command. Yeah, again, we see here is just written that on this element, on this face of this element, this magnitude of force has been applied, and there's no command. Whatever is coming after 2 star is just a command. So that's why here, before including the load file, we have written these commands in order to force the information of this file load.dlo to get into CCX. That's one thing. And then those two commands, not file and l file, they are just going to give results to the output. Not file is going to give displacement of the nodes to the output, and l file is going to give the shear stress results to the output.